Hi everyone. So I'll be going through the recursion and financial modeling section of the 2019 multiple choice exam. So question 17, consider the recurrence relation shown below. The value of A3 in the sequence generated by this recurrence relation is given by. So basically we've got to find the value of A3. So to do this, use the formula they've given you. So we find A1 first. So it will be 2 times 3 plus 4, which equals 10. And then you got to find A2 by using the value of A1. So 2 times 10 plus 4, which equals 24. And then you find the value of A3 by using the value of A2, which is 2 times 24 plus 4, which equals 52. So one of the following multiple choice solutions has 2 times 24 plus 4. And if you look at D, it has the same thing here, 2 times 24 plus 4. So therefore D is your correct option. Question 19. Jeff purchased a computer for $4,500. He will depreciate the value of his computer by a flat rate of 10% of the purchase price per annum. A recurrence relation that Jeff can use to determine the value of the computer after n years, Vn is. So I've written the rule for the recurrence relation of a flat rate depreciation over here. So we know that V0 is 4,500 because Jeff purchased the computer for 4,500, so that's basically the initial value. And then Vm plus 1 equals Vn minus something, which is the question. It says he would depreciate the value of the computer by a flat rate of 10% of the purchase price per annum. So basically D equals 10% times the purchase price, which is 4,500, which equals 450. Therefore D is 450. And then this is your answer. Now let's look at the multiple choice question solutions, and then A is the correct answer. Question 20, consider the following amortization table for a reducing balance loan. The annual interest rate for this loan is 3.6%. Interest is calculated immediately before each payment. For this loan, the repayments are made. So to do this question, we have to find the interest rate between each payment number. So to do this, to define the interest rate between each payment number, I'll do 900 divided by 300,000. So when you do that, 900 divided by 300,000 times 100 to find the interest rate. Put that on your CAS calculator, and you get 0.3%. So to find whether the repayments are made weekly, fortnightly, monthly, quarterly, or yearly, use the annual interest rate divided by the interest rate for each payment. So 3.6 divided by 0.3, which gives you 12. So therefore the repayments are made monthly. So C is the correct answer. Question 21. The graph shows the value in dollars of a compound interest investment after n compounding periods, Vn, for a period of 4 compounding periods. The coordinates of the point where n equals 2 are n, b. The value of b is. So to do this, I basically found the recurrence relation and the nth term relation. The initial value in dollars is 500, which we have from this point. And so basically I converted the recurrence relation in an nth term relation to help us find the value of r. So to find the value of r, I can sub any of these points into the equation to find the value of r. So if you sub, let's just take this coordinate for an example. We sub the value is 580 equals r to the power of after 1 year, after one compounding period, times 500, and you put that in your CAS calculator and solve for r, and you should get r equals 1.16. So therefore, with the rule, nth term relation rule is Vn equals 1.16 to the power of n times 500. So if we sub n equals 2 to find the value of p, 1.16 to the power of 2 times 500, put that on your CAS calculator, and you should get 672.80 and therefore the value of B is 672.80, and therefore C is the correct answer. Question 22. A machine is purchased for $30,000. It produces 24,000 items each year. The value of the machine is depreciated using a unit cost method of depreciation. After 3 years, the value of the machine is $18,480. A rule for the value of the machine after n units are produced, Vn is. So to do this, we have to know the formula of the unit cost depreciation, the after n units are produced. So this is the formula of a unit cost method of depreciation. V0 represents the initial value of the machine. So therefore we know that Vn must equal 30,000 minus Dn. So we have to find what the value of D is. So to do this, we have to find how much the machine has depreciated over the over 3 years, because this is the value of the machine after 3 years. So to find the value of to find how much the machine has depreciated over the past 3 years, you do 30,000 minus 18,480, which gives you $11,520. So that's how much the machine is depreciated over the past 3 years. So we got to find how much the machine is depreciated each year. So to do this, you do 11,520 divided by 3, which equals $3,840. I divided it by 3 because this value here is how much the machine is depreciated after 3 years. So to find how much the machine depreciates every year, we got to divide that value by 3. So the next step is to find how much the machine is depreciated per item produced each year. So to do this, you divide this value divided by 24,000 items produced each year, which gives you $0.16. So that's how much the machine is depreciated per item produced. So that means we sub this value as D into the equation. So Vn equals 30,000 minus 0.16 n. Therefore, the solution is E. Joseph borrowed $50,000 to buy a new car. Interest on the loan is charged at the rate of 7.5% per annum, compounding monthly. Joseph will fully repay this loan with 16 monthly repayments over 5 years. Immediately after the 59th payment is made, Joseph still owes $995.49. The value of his final repayment, the nearest cent, will be. So basically, we'll just insert the information given from the question into your financial solver on the CAS calculator here. So basically, first statement is Joseph borrows $50,000 to buy a new car. So you put $50,000 as your present value, and you make sure that the value is positive because this is money Joseph has borrowed. Interest on loan is charged at a rate of 7.5% per annum, so 7.5. Compounding monthly, so therefore compounding monthly is 12. Joseph will fully repay this loan with 60 monthly repayments over 5 years. So that just tells you that the loan will last for 60 monthly repayments over 5 years. Immediately after the 59th repayment is made, so after the 59th repayment, Joseph still owes $995.49. So we don't know what his payment initially is, but we don't need to know that. We need to find his final payment. So his final payment means that there's one payment remaining, and the amount left, future value after 59 payments, becomes the present value to find the final payment. So you put that as negative because this should be negative here. That's my bad. Future value should be negative because this is the amount of money he still owes. But when you move it into present value, it becomes positive. And it says he repays the loan in 60 monthly repayments. So one more payment should result in a future value of 0. So therefore, all we need to do now is just find the payment. And if you put that on your calculator, you get $1,001.71. So therefore C is the correct answer. Question 24. Millie invested $20,000 in an account at her bank with interest compounding monthly. After 1 year, the balance of Millie's account was $20,732. The difference between the rate of interest per annum used by her bank and the effective annual rate of interest for Millie's investment is closest to. So basically, same as the previous question, we just got to insert the information given in the question into your finance solver on your CAS calculator. So Millie invested $20,000 in an account. So you put that as negative because she's invested the money in the account as your present value. So negative 20,000 with interest compounding monthly. So interest compounding monthly is 12. After 1 year, so 1 times 12 because interest is compounding monthly, which is 12. So you put N is 12. The balance of Millie's account was $20,732. $20,732. Put it in as positive because this is the amount she has in her account. The difference between the rate of interest per annum used by the bank and the effective annual interest rate for Millie's investment is closest to. So we have no information about payments. She's just investing her money in the bank, so the payments are 0. We got to find the interest rate. Put the values on your CAS calculator, and you'll get 3.6% as your interest rate per annum. So now we've got to find the effective annual rate of interest. So if you've got a CAS calculator, you can put menu 852. If you go menu 582 on your CAS calculator, you'll be able to do you'll get something that says effective, and you just got to insert the annual interest rate 3.6, comma how your compounding periods, and your compounding periods here are 12. So that will give you the effective interest rate, which equals 3.66, the 2 decimal places for now. If you don't have a CAS calculator, you can just use the effective interest rate formula, which is equal to, I'll just write the formula over here, 1 plus R divided by your compounding periods on 100 to the power of your compounding periods minus 1 times 100. So you can just substitute 1 plus R, which is 3.6, on your compounding period. So R represents your annual interest rate on 100 to the power of, your compounding periods are 12, to the power of 12 minus 1 times 100. And that will give you the same thing, 3.66. So if you do so we want to find the difference between the rate of interest per annum and the effective annual interest rate. So you just subtract the effective interest rate, 3.66, minus the annual, 3.6, which gives you 0.06. Therefore, B is the correct answer.